Hey guys, today we're going to be looking at stoichiometric ratios. I'm actually going to break this video down into two different parts because what I want to go through in this part is really about how we go about balancing equations. In the second part of the video, we're going to start to talk about excess and limiting reagents. Alright, so we've got some vocabulary words there. So stoichiometry, reactants, products, and those are the three words that I really want you to define for this video. The next video, we're going to be looking at limiting and excess reagents. Alright, so let's talk about what stoichiometry is first of all. So really simply, stoichiometry is just the science of balancing equations. Your textbooks define stoichiometry as the use of mathematical calculations to determine the relative quantities of reactants or products formed in a chemical reaction. That's pretty complicated. That's why I just like calling it the science of balancing equations. I actually really like the word stoichiometry too. It's just like a really fun word to say. So the whole idea of this science of balancing equations, stoichiometry, comes about because of the law of conservation, which is that energy and matter cannot be created or destroyed. So basically, if we were baking a cake, right, you'd need 2 eggs, you'd need 100 grams of butter, you'd need a cup of flour, whatever. If you don't have, exactly those amounts, then you're not going to be able to make your cake. You can't just magically produce an extra egg out of thin air. So you need to have those amounts indicated before you go ahead and make the recipe. So this is kind of the same thing with balancing chemical equations. So I've got a really simple example to start off with. So hydrogen gas burns in the presence of oxygen. Write the balanced chemical equation. So when we do this, I'm going to be using a few little notations. So just so that we're familiar with that, if I do a little symbol like a little G, that means that the compound is going to be in a gaseous state. If I use the symbol L, that means it's going to be in a liquid state. If I use the symbol S, that means it's going to be in a solid state. And the last one, and this one's a little bit funny, is the term aqueous. And aqueous just means that it's going to be dissolved in water. So for example, if I had sodium chloride, I could have sodium chloride as the solid salt, or I could have sodium chloride as a solution. Okay, so that's just to show you the two different forms that we could have. All right, so we've got hydrogen gas, so I'm going to use hydrogen, it's H2 for gas. So hydrogen gas plus oxygen, because it's burning in the presence of oxygen, and oxygen gas is also going to be O2. And that's going to produce a compound called water. And water, as we know, is a liquid. Okay, so what I'm going to do is I'm going to look at the numbers of hydrogen and oxygen on each side of my chemical equation. So on this side of my chemical equation, I have 2 hydrogens and I have 2 oxygens. On this side of my equation, I have 2 hydrogens, but I only have 1 oxygen. So what I'm going to do is I'm going to double the amount of water on this side, and so that's going to double all of these values here. So I now have 2 oxygens, and I now have 4 hydrogens. So these two are now balanced. The last thing that I'm going to do is back on this side of the equation is I'm going to double the amount of hydrogen so that I now have 4 hydrogens on this side. This equation is now considered balanced because I have equal numbers of hydrogen and oxygen on each side of the equation. All right, so I want you guys to go through and I want you to have a go at these questions here. So what I'm going to do is I'm going to get you to pause the video and then I'll go through the answers with you after the break. All right, let's start off with this first equation here. So we've got iron plus oxygen turns into iron oxide. Now, they haven't actually put any of the those symbols like liquid, gas, whatever. So we're going to pop those in. Now, iron, as you know, would be a solid at room temperature, and oxygen gas, as we know, is a gas at room temperature, and that's going to produce, sorry, I should use the proper terminology here. I should use this little arrow, and that's going to produce iron oxide, and this is going to be a solid. So if you think of this, this is like rust. Okay, and there are 2 different kinds of rust. There's like a red colored rust and there's a black colored rust, and that depends on whether it's going to be iron 2 oxide or iron 3 oxide. All right, so let's go ahead and let's balance these equations now. So I've got iron and I've got oxygen for each side of our reaction. So if I have a look at this first side, I've got 1 iron and I've got 2 oxygen atoms. Let's do the same thing on the other side. So I've got 2 ions, and I've got 3 oxygens. So I'm going to need to balance this. Now here's a little trick. What I'm going to do, I can see because I've got 3 oxygens on this side and 2 oxygens on this side, I'm going to cross multiply. Okay, so what that means is I'm going to pop a 3 out the front here, and I'm going to pop a 2 out the front here. So this is going to change both sides of the equation. So I'll start off with this one. So I now have 4 ions on the right-hand side, and I have 6 oxygens on the right-hand side. If I go over to this left-hand side, I've got 6 oxygens on the left-hand side, and I've still got 1 ion. So all I'm going to do to balance these is to write a 4, and then I now have 4 ions on each side. I'm going to clear the page, and I'm going to come back and do the second example. Okay, also, by the way, if you haven't actually had a go at this and you're still a little bit stuck, you can pause this video at any point and then just, because I'm going to go through the answers one by one, so you can actually have some time to reflect on what each of these processes are. All right, so let's go through, and again, let's write our little symbols in for the state of matter that they're in. So hydrogen is a gas at room temperature. Chlorine is also a gas at room temperature, and that's going to produce hydrogen chloride. And I'm pretty sure most of the time this is in solution, so I'm going to assume that that's going to form a solid. I could look this up, couldn't I? A little bit tricky to do while I'm trying to teach it, but that's all right. I'm just going to assume it's a solid. Because hydrogen chloride is technically a salt, and we know that most ionic compounds are going to be solids at room temperatures. All right, so let's write out, we've got hydrogen on one side, we've got chlorine on the other side, and we've got 2 on the left side for each of the hydrogen and the chlorine atoms, and then we've got 1, this is going to be a nice simple one. All I'm going to do is I'm going to double the amount of hydrogen chloride on this side, whoops, and that's now going to give me a balanced equation. Nice and simple. Again, I'm just going to go away and clear this if you want to have a go at the next question, and I will be back with you after the jump. All right, so this next one, we have silver is reacting with hydrogen sulfide to produce silver sulfide and hydrogen. Now, this is actually a replacement reaction. So what I mean by replacement reaction, effectively the silver is coming in and replacing the hydrogen. So this is actually going to be a pretty straightforward one. I really like balancing ionic compounds. Ionic compounds I find are a lot easier to balance than what covalent compounds are. So let's go through. So we've got silver, which is going to be a solid at room temperature, plus hydrogen sulfide. Now I'm going to assume that this is dissolved in a solution, because most acidic compounds, or most ionic compounds are going to be dissolved in water when you're mixing them with a solid compound. And that's going to react to form silver chloride and hydrogen. All right, so again, let's just write down each of our chemical species. So we've got silver, we've got hydrogen, and we've got sulfide. Okay, so on my left-hand side, I've got 1 silver, I've got 2 hydrogens, and I've got 1 sulfide. On my right-hand side, I've got 2 silvers, I've got 1 sulfide still, and I've got 2 hydrogens. Okay, so for this one, what I'm actually going to do, I think I might start off with, well, the hydrogens are already balanced, because there's 2 hydrogens. The sulfides are already balanced, so the only thing that we've got left to balance is going to be the silver. So this is going to be a nice easy one. All I'm going to do is pop a 2 out the front, and now I've got a balanced equation. So some of these are going to be really, really simple. Up next, we've got an example where it's going to be a little bit more complicated, because we're actually dealing with covalent compounds and not ionic compounds. So if you want to have a go, pause the video, and I'm about to go through this this fourth answer. All right, let's start off. Let's write our reaction out. So we've got CH4. Now, CH4 is methane, so that's going to be a gas at room temperature. Oxygen, we already know, is a gas at room temperature, and that's going to form carbon dioxide, which is also going to be a gas at room temperature, and water, which is generally a, I'm running out of space, sorry, which is going to be a liquid at room temperature. Okay, so let's write out all of our individual elements. So we've got carbon, we've got hydrogen, and we've got oxygen. Okay, so on the left-hand side of my equation, I've got 1 hydrogen, 1 carbon, 4 hydrogens, and 2 oxygen atoms. On the right-hand side of the equation, I have 1 carbon, I have 2 oxygen, three oxygens, because I've got this one here in the water, and I've got 2 hydrogens. Okay, so this one here, we can kind of already see straight away that we're going to have some issues. With odd numbers, it always is a little bit trickier, so I always just kind of know that if I see an odd number, I'm probably going to have to cross multiply. But this is a little bit different because we've actually got 2 of the oxygens in the carbon dioxide and 1 of the oxygens is in the hydrogen. The water. So what I could do, if I double just the oxygen, just the water, then that's going to double the hydrogens and it's going to double this oxygen. So now we have 1, 2, 3, 4 oxygens. Okay, so we've got our carbon that's balanced, we've got our hydrogens that are now balanced. The last thing we need to balance is going to be our oxygen, and that's going to be pretty straightforward to do. So now we have a balanced equation. So these ones do start to get a little bit trickier because you have sort of different spots where you have things like oxygen, or you might have like a lot of hydrogens. Like for example, if when this burned, it burned not completely, you might have some hydrogens that would still be present within this carbon molecule. So these ones do start to get a little bit trickier, but again, if you just go through the process, it's pretty straightforward. This one here. All right, this one here, I'm not even going to bother to draw out my equation because you can kind of already see what it's going to be. If I double the amount of this compound, so that's mercury oxide, then I've got 2 mercuries and I've got 2 oxygens on this side. I've got 2 oxygens on this side, so now I need to do is just balance 2 on this side. All right, let's do the last one. Again, I'm not going to bother drawing out a table because I'm pretty confident at this, right? So I've done this like a lot. So if you guys want to draw the table, I would highly suggest doing it. But for this one, I'm not going to do so. So we've got 2 cobalts on this side. So I need to double the amount of cobalt on this side. Now for this one, I've also got 1 oxygen on this side, 3 oxygens on this side. So I'm going to triple the amount there. So now I've got 6 hydrogens, I've got 3 oxygens, and I've got 2 cobalts. Last thing I need to do is I need to balance out the hydrogen. So I've got 6 slots of hydrogens on this side, I've got 2 on this side. So if I triple this, then I'm going to have 6 slots of hydrogen on this side, 3 oxygens, 2 cobalts. So everything balances out. All right, so this video was mainly focusing on the balancing of chemical equations. So the next video, what we're actually going to look at is we're going to start to look at stoichiometric coefficients, stoichiometric ratios, and we're going to start talking about excess and limiting reactants. All right, see you in the next video.